Thank you all for coming out tonight. My name is David East. Like I said, I work at Firebase. And tonight, I want to talk about something a little bit important before we get going. So it's Monday. I take it that none of you are big Cincinnati Bengals or Houston Texans fans, or otherwise you'd be watching Monday Night Football. But if you so happen to be following the game through any capacity, let me know if Andy Dalton scores, because I need like 8 points in my fantasy league to win, and I'm playing against my brother, so like that would be really cool to especially know on camera that I beat him. So I'm really looking for those bragging rights. But tonight I'm going to talk about what Firebase is and how we can make apps for Firebase. So I'm going to be doing a lot of stuff in this talk. And I'll send this link in these slides out later. But this right here is a great article that I'll kind of narcissistic to call it great since I wrote it. But the website's raywunderlich.com. If you've heard of raywunderlich.com, you know they have just amazing iOS tutorials. And I was privileged enough to have them let me write an article for them. And so it's all about getting started with Firebase. And it basically covers this and like way more of what I go in tonight. So if you're really curious, this link will get you there. So tonight we're going to talk about Firebase and how we can use Firebase to build apps fast, or build powerful apps fast and then scale. And so to really talk about this, I want to go to a story of one of our customers that I find really interesting. So one of our customers is Sky News, and they're one of the biggest news companies in the United Kingdom. And they had a really big challenge last year, and they had to cover the UK's general election. So is anyone here actually from the UK? Okay, so the way elections work in the UK is so much cooler than the way they work here in the United States. So the way it is in the United States, like it's kind of confusing and a little like boring. Like every 4 years we have the presidential election, and every 2 years we have midterm elections where all the representatives go up for election, but only like a third of the senators. And it's confusing, and it probably explains why not everyone votes. But in the UK, it's so much more cooler. If that more cooler, but all right, it is super cool. So every 5 years, everybody gets fired. Like, absolutely, like there's not a single person in the House of Parliament every 5 years. So like, this isn't even just like, oh, haha, you're kind of fired. No, they like make you pack your bags and leave. Like the entire office is empty. So there's pretty much no one running Parliament for 25 days. So if you are a member of Parliament, you have 25 days to convince everyone that you should be elected again. And what's cool about this is that the entire House of Parliament is up for an entire scramble. So this is like the equivalent of like the Hunger Games for politics. Like everyone is fighting for power. And if you're a voter, this is super cool because this is really interesting. And it's a total fresh start for for essentially the entire House of Parliament. But if you're Sky News, this is a pretty big problem because you're provided with a short time frame to build an app that covers the election. And this happens every 5 years. So like, what are the chances that your app from 5 years ago is still good today? I mean, 5 years ago, they weren't even making apps. And they came to us because they told us, we want to build a system that beats TV. We want to give everybody a better way and the fastest way of seeing election results and provide our users with the most immersive experience. Because it's not enough anymore to just be on TV or have a newspaper or whatever. You have to go to where the user is, which we're always on our phones. So they built a mobile web app that essentially was this map with all these hexagons representing each district in the United Kingdom. And when the polling results changed, the map color would change in real time. And you could click into that and you could see all of the real-time voting in each district in real time and the overall all in real time. And this went over really well for them because on election day, it ended up being the most watched general election in UK history. And millions of people came to their website that morning. And at any given point in time, you could see 500,000 people all concurrently on their app. And all of this was powered through Firebase. So they were able to build an app and just focus on their user features and not care about writing networking code, writing server code, or maintaining any server deployments, and just focus on the things that matter and build it fast on a short time frame, and then scale out to millions. So that's really what I want to kind of keep in your minds tonight. That's what we're looking to do, is we don't want to be bogged down by lots of networking code and lots of other things. We want to just build the things that the user cares about. So Firebase has 3 main features that allow you to build fast and scale. And the first is user authentication. So this is essentially not writing any of your own login code and using Firebase to do all that for you. And then also there's the real-time database, which is a lot of the magic of Firebase. And this is cloud hosted, so there's no setup involved for you. And there's also static hosting, which is great for building single-page applications as well as app landing pages. And tonight we're going to focus on mostly user authentication and the real-time database. So throughout this, we're going to be building a grocery list app. And so everything that I'm going to be showing, just think about the data that it would be in a grocery list app, or think about how you would integrate this into an app yourself. So we'll start out with the real-time database. And this is this really cool graphic. This is one of my favorites. So essentially the way the real-time database works is that when you have a Firebase app and it updates the server or the database, every single client, so every other device that is listening, gets that update pushed down to them. And essentially what you need to focus on is how it gets pushed down to them. It's not a request response protocol. So things like pull to refresh, they don't exist in Firebase apps because the view is always up to date. So we don't have to do any request out to the server. We're getting updates delivered to us. And so the way you connect to a Firebase is we have an iOS SDK, which you can install via CocoaPods. So if you're a CocoaPods user, actually, out of curiosity, raise your hand if you use CocoaPods. Good people. Love CocoaPods. All right, so after you've installed the SDK, you have access to this Firebase class. And this is where actually the majority of your Firebase code is. There's not like a ton of types and classes to learn. This is actually like 90% of the time you'll be using this class. And to create a reference out to a database, so essentially a connection, you initialize this class with a URL. And this URL is given to you when you create an account, and this essentially points at a location in Firebase. So my name of my Firebase is grocer app, and then my location I'm pointing at is the grocery items. So I can actually stream or save data to this /grocery items since I made a connection to it. And what's important to understand is, and this is truly like once you understand this, magical things start to happen. If you know that all the data that's being stored in Firebase is just a JSON object, and that's really it. And so since it's a JSON object, every single piece of data in the database has its own URL. So it's all completely RESTful. And so let's take a look at a piece. So this could essentially be the data in a Firebase database. So you can see at the very top, there's comments on each level of what the URL would be. So in the top one, we can see that that's the root. And so if we wanted to get data from there, we would get data from everything else underneath because that's the tree. But maybe we just want to get the grocery items. Well, /grocery items are all the grocery items. And maybe we just want to display a page of the milk. Well, /grocery items /milk just gets you to the milk. And you can see it even maps down to each individual property name. So if you have a piece of data in Firebase, it has a corresponding URL. And when we plug these into Firebase references, this is how we can save and sync data. And there are multiple ways of creating Firebase reference, and you can use a full string to get out to the data, or you can programmatically call child by appending path to create child references that go to the child locations. So that's how we actually store data in Firebase, and that's how we create the reference. But saving data is pretty simple. So in this case, what we're doing is we're creating another Firebase reference, and then we're storing it at /grocery items /milk. So we're just we're just connecting out to the milk. And so what we want to do in this case is we want to say that it was completed. Well, we can call set value, and we pass in a dictionary, and the key value is completed, false, and then now we can say that this milk hasn't been bought yet. And so that's saving data. It's pretty simple. And the real magical part of all this is syncing data. So rather than connecting out to one item, we're going to go back up the tree, and we're going to go to /grocery items. And at this point, we're going to synchronize data. And to synchronize data, we call the method observe event type. And we can specify what type of events we're interested in listening for. And so in this case, we're using the value event. And the value event is sort of like your catch-all. So anytime anything happens, something gets added, deleted, changed, really anything, you'll get back the object in its new state. And this returns to you in a snapshot, which just isn't just your data. It's also a lot of helper methods to help you iterate on your data or get metadata about your data. And if you do want the data, you just call the value method, and it returns to you as a dictionary of string any object. This is for Swift, obviously. So this is really cool. Like, you know, you guys are actually, believe it or not, like, well, I've been up here for like 5-10 minutes. You're pretty much Firebase pros. Like, that is as simple as it is. So, like, come on, slow clap. Let's do it. All right. So that's pretty much like, that is the most of the stuff you need to know. Like, I have a JSON database. I can save data. I can sync data. Like, I know how to build. If you know how to build an iOS app, you can go really, really far with that. So with having a great connected app, though, like what happens when the connection drops? Like there's usually a lot of times when the internet goes out on our apps, we can usually present them with a screen being like, "Oops, don't have internet. Come back later." But with Firebase apps, it's a lot different. So we have full support in offline. So how your app would work online, it works pretty much the same way offline, but at a local level. So all the same synchronization events, all the same saving, all that still works, but it works off of the local disk. So it can even survive through app restarts. So if your app suddenly goes offline, all those writes, all the synchronizations, they still happen, and they all save to your device's local disk. And then when it goes back online, that's when it synchronizes with the server and then gets you right up to date like you were never offline. And to use this feature, it's not so much something you have to be aware of. It's really baked in to Firebase itself. You just have to say that you want to opt into it. So you essentially say persistence enabled is true, and that's it. You have an offline enabled app, and you don't have to do anything other work on it. So at this point, we have seen all the stuff we have to do to read data, sync data, make things offline. But we saw that when we structured data, everything had its own piece. Every piece of data had its own URL. And if you can use that URL, then you can use that URL. And then you can use that URL. And you can use that URL. OK, sorry, I wanted to have an Oprah moment for once. But essentially, it's publicly available for everybody. So how do you secure that? Because we're only writing client-side code. So what prevents me from just sending a delete request to the root and just totally wiping out your database? So we have our own way of securing things. So if your data is JSON, then we have rules that map to that data structure that are also JSON, and they can say what can be read and written to your database. So we call these security rules, and they're essentially annotations on your JSON data structure. So right here we have a key for foo, and foo essentially would be /foo on your Firebase. And there are 3 types of rules. There are read, write, and validate. So read is who can read it, and write, obviously, who can write to it. And validate is what does this data have to look like to be written. And so in this case, every single one of these has to evaluate out to an expression, so true or false. And we're saying anyone can read it, anyone can write it, but if you're going to send data to foo, it better be a string, and it better be less than 100 characters. And that is enforced on the server level. So there's nothing anyone can do on the client level to modify that at all. And you can see there's even that special variable right here, which is new data, and that is the actual data that's trying to be posted to your Firebase. So that's how we secure apps, but security is kind of hollow unless you can log in users. So next we're going to cover how we can handle authentication in Firebase. So there's multiple types of authentication. We have email and password, and we also have third-party providers like Google, Facebook, Twitter, and GitHub. So that handles a lot of your OAuth flows. And out of curiosity, how many people have written their own OAuth server before? That's why you're all so happy. It's not a lot of fun. So this is also pretty simple. We create a connection out to our Firebase, and so our Firebase database, and we don't have to supply any types of like paths or child paths at the end because we just need a connection. We're just logging the user against that Firebase database. And this is email and password. And all we're doing is we're logging in someone by passing in an email and their password. And when the server gets back to us, it'll either return to us an error or the user. So we can guard against that user and see or guard against the error. And if there's an error, we could log it, do something off of it. Or if that error is not there, we have an authenticated user, and that's what the auth data is. It's actually a type called fauth data that contains all the information about the user. So if it's email and password, you will get their email and you'll have a unique identifier for them. But if you choose any of the social providers, you'll also get you can pass in scopes to get in social data. So depending on how flexible the social provider is, you could get back their email, you could get back, I think Facebook, you can do stuff to get back friends, and so you can get back other information with Twitter, you can get back their Twitter handle and stuff like that. And what's great about this is once we can log in users, now we can write really robust security rules. So this is a really small snippet of security rules, but it's probably one of the most commonly written in all Firebase applications. Because essentially what this rule says is that if you want to write data to the users node, or read or write data, you better be that user. And that's all it is. So what's great about this is that we say, okay, we're creating a rule for users, and then we have this $UID. And that's essentially just creating a variable. I could call it whatever I want to, but $UID just makes the most sense. And then now I can check against a special variable on the server called auth. And I can say, if that UID, which essentially is kind of like a route parameter, so it's variable, it's whatever users slash whatever they're trying to access, if it's users slash that UID equals the currently logged in user on the server, you can read or write to it. And that's absolute user-based security in just a small amount of code. And what's great about that too is that that's all the security code you have to write. You don't have to write anything else. It's like I used to write lots of backends where we would write security code in like 16 different places, and then we'd have to update the rules, and you'd be like, okay, let's weed them all out, and then one never ends up being like all of them. So this is just one place to write your security rules. Yeah. So the user is synchronized against the the user is synchronized on the client and the server. So it's the same identity throughout both. So you you don't have to worry about keeping track of multiple identities. Are you talking about being like logged in through like a different account? So yeah, you could create a location that just maps who. So if you want to log in through like 4 different providers, we have a sample on every platform of how to do that. It's pretty simple to do. You just save one common ID for all of their social login IDs. And then if it matches that when you're trying to log, you can write a rule that does that as well. And then it matches who they are. So feasibly you could log in with every single social provider and email and password, and it would bring you to the same data with the same identity. Yes, you could do that, yeah. Yeah, the rules grow a little more when you do that because you have to write more checks, but it's still totally possible, and it works more or less the same way as this. So now that's pretty much how, like the fundamentals of Firebase. It's reading data, writing data, structuring your data, and logging in users. And that's pretty much how you do it, but we kind of did that by itself in a vacuum. We didn't really look about how that actually applies to Firebase, like how it applies to iOS apps. So if you're an iOS developer, you're pretty much spending every day of your life with UI kits. And a lot of probably the number one asked question for Firebase and iOS and Stack Overflow is how do I synchronize data to a UITableView? Because pretty much 90% of the App Store is a UITableView controller. So that's pretty much what we're building all day long. And doing this is really easy. So we just subclass the UITableView controller, create a Firebase property, and we create our data source, which in this case is just an array. So in view did load, this is where we would create our Firebase instance. Since you can't rely on init with the view controller, you can do all your initialization stuff in view did load. And then what we can do next now in view did appear, this is when we start synchronizing data. Because we don't want to synchronize in view did load because you may not be on the screen all the time in view did load. And you want to be very cognizant of the user's battery life. So if you only synchronize when you are actually on the screen, then you're being a good citizen. So in this case, we're not using the value event when we're observing. We're actually using the child added event. And child added is different than value. So with value, every time anything changes, something gets added, something gets removed, a property gets changed, you get that entire updated object back. With child added, it's an event that's used for maintaining lists. So every time something gets added underneath a path in Firebase, you'll get just that single item added, which is really great for when you want to see if something gets added to a UITableView. And in this case, whenever a new item comes in, we can create a grocery item from the dictionary. We append that to our local data source. We create the NSIndex path that the UITableView demands of us, and then we just insert it into the table view, and then in real time that gets added to our table view. And this essentially eliminates pull to refresh because your table view is constantly up to date. And so if you thought that was hard, which we did on Firebase, so we actually went out and built a library called, I'm going to go back, library called Firebase UI. And so you can see this up on GitHub. It's github.com/Firebase/Firebase UI. And essentially what this is bindings for UIKit in Firebase. So you create something called a Firebase data source, and you pass in the data source, we pass in the Firebase reference and your table view. And at this point then with the data source, you just call populate cell with block. And what this does is it returns to you your UITableView cell, and your data from Firebase. So when they're paired up together, you just populate the cell with any changes. And this works for every single, and we synchronize every event in Firebase. So there, as you saw value, you saw child added. There's also child changed and child removed. So there's different ones, and we actually keep track of every single one behind the scenes, and that keeps your UITableView completely up to date. And there's even other ones for UI collection view as well. Another thing is segues. So essentially when we log in users, we want to be able to say, I logged in, now go to this page, or go to this controller. So we really want to be able to trigger a segue after we sign in. And to do that, we essentially could create a IB action where we say login did touch. And at this point, what we'll do is we'll log in that user. We can guard for an error, but if it was successful and we got a user back, we can call perform segue with identifier and go to our desired view controller. And one thing you might notice here is in the sender, where we usually want to populate that with data, we actually don't have to put anything in here. We don't actually pass in the user. And that is because when we intercept the segue and prepare for segue, we grab the destination view controller, and then we can populate it with whatever properties we need. But you can see here we have ref.authData. So whenever a user gets authenticated with Firebase, who they are is available on every single reference you create, no matter how many you create or which one you created. That authenticated user is always there as long as you're logged in. So the last service to talk about is hosting. So Firebase has a hosting product for hosting service for static hosting. And since it's all static, like HTML, JavaScript, CSS, image files, we can actually back these by a CDN. So it doesn't actually really matter where your website is in the entire world. It will be served by a local POP in that area. So if someone is in New York or someone is in India, it'll serve from the closest POP from them. And this is for every single file that's hosted through Firebase hosting. And also what's pretty cool is so Firebase requires all SSL traffic to be used. There's no HTTP, it's all HTTPS. So our hosting service gives you a free SSL certificate that you don't have to set up just right out of the box. And this works really well when you're trying to build a single page app or whether you're trying to build an app landing page. And my favorite part about actually using Firebase hosting is the fact that you can do it all from the command line. And it's really like, 2 lines of code to do a deployment. The first thing you do is you would call Firebase init, and that's kind of a one-time thing, sets up your Firebase. It'll tell you when it's done. And then at that point, you can call Firebase deploy. And that right there just sends it out. And you're pretty much done. Once it finishes uploading, that's all you have to do. So another thing, actually was one of my first projects when I first joined Firebase was redoing all the documentation. So we're kind of a documentation first company. So when you go out and you see all this, and if you're excited and you want to build something on Firebase, the documentation at firebase.com is not really going to let you down. We are kind of like obsessed with making sure we have great documentation. So if you go to firebase.com/docs, you can see that we have a whole doc sets for all the platforms that you can write with Firebase. And if you go into iOS, there are multiple ways of figuring out information. We have a 5-minute quick start, so it'll just teach me how to install it and do some of the basic things that I taught you guys tonight. But if you really want to get deeper, you can click on our guide. And this will take you through 1 through 8 of how to do pretty much 0 to 60 with Firebase. So if you went through this entire guide, you would be like a pretty advanced Firebase user. And a lot of times when you learn of a new technology, you rely a lot on outside tutorials because the documentation is all that great. You're not going to really find that a lot with us. We have a lot of information on our stuff. And even to the point where we have a full API reference, we have a lot of example apps, and pretty much throughout wherever you go in our website, we just have every piece of information. We even have an entire guide that teaches you how to use Firebase with WatchKit, so if you want to build Apple Watch apps. So next thing I want to do is kind of show you kind of like the magic of Firebase. So if you pull out your phones and go to this URL, you're going to go to a mobile web app. And I'm going to open up an iOS app. So while this is on 2 totally different apps on 2 totally different platforms, we're going to see some of the magic. And this is pretty much the grocery app that we've been building throughout the night. All right. Oh, I can see that. So this is my app right here. And that's 7 right up here. I can see that, including myself, that there's 7, 8. This is in real time. I'm getting updated when people join the app. And then now people are asking for bananas, milk, and I can ask for stuff. You check things off. You can swipe to delete. So now this is essentially, you see there's no need to pull to refresh. This is an iOS app. You all are using a web app that essentially does the same thing, and it's a cross-platform real-time experience. I like that someone put new iOS app with Firebase. It's a thumbs up from me. Now, this is the code for that. Let's go back into here. So from there, if you really want to, like I said, dive deeper into all this, the Ray Wunderlich tutorial pretty much teaches you how to build everything that you use in that app, and actually a lot more, and goes really heavy into the details. So it provides you with a good, from start to finish guide. So I do recommend checking that out. And so essentially what I've been trying to show you guys tonight is that when you build an app with Firebase, you can get these services like authentication and real-time database and hosting. And this is all the server infrastructure and all this networking code that we don't have to worry about. Because at the end of the day, you're never going to hear a user give you a 5-star app review and say to you like, wow, this app is so good. I can tell it uses a lot of databases. It's really great. Like, you're never going to get that. But if you ever do get that app review, like, email me with a snapshot of it because I would love to see it. Like essentially having server infrastructure and networking code is kind of like being a field goal kicker in the NFL. When you kick that field goal, a game-winning field goal, everyone's like, congratulations, you did your job. But when you miss it, they pretty much cut you from the team, like the user deletes your app. So we want to spend our time focusing on the things that matter, so the user-facing features, rather than dealing with server infrastructure and the stuff that scales. So that is my talk. If you have any questions, you can obviously ask me them right now, or if you don't want to come up and say anything, I am _David East on Twitter. I'm a JavaScript private variable. So if you want to say anything at all to me, you can tweet at me there. So thank you all so much for coming out tonight, and I am totally ready for your questions.